Okay, as you guys might recall, this lesson was pretty challenging in class, wasn't it? So, what we're going to be talking about today is combining um, uh, different functions, different terms that have the same period. No, this has a period of 3t, and this has a period of 3t, but the phases are different. So this is shifted pi over 3 to the right, and this is shifted pi over 6 to the left. And we're going to be showing how to add those together. In addition, we're also going to our amplitudes are going to be different too. So and this is the result of the answer. We'll just talk about that in a second. So so here I've got two functions. One of them is 10 cosine 2t, and the other is 7 cosine 2t plus 3. Okay, so you might recall when we did H8E.1, we talked about how to convert from Cartesian to polar to Euler form. And one of the things that's important to remember is that when we have something in Cartesian form, we could figure out the magnitude, and we can also figure out our direction in the imaginary direction. We can express that as sine theta w, and our direction and length in the x direction, or the real direction, as cosine magnitude times cosine theta. So, and we kind of get lazy, and instead of writing out cosine theta plus sine theta, we can just simply simplify that as cis theta. So now this here says cosine. So I'm going to need to use I'm going to use complex numbers and Euler's form to solve this problem. And so I can write this in terms of cis, but in order to do that, since it's in cosine, that means the cosine is the real part, or the part in the x direction, which is the real part. So I'm going to write this as 10 cis 2t plus 1 plus 7 cis 2t plus 3. All I did was, instead of writing cos, I wrote cis. Instead of writing cos, I wrote cis. Everything is also exactly the same. And the reason I can do that is because I'm only looking at the real part. And if I'm only looking at the real part, then I can basically, I've got Euler's formula, but I'm only looking at the real part. Okay, so now I'm going to convert this from polar form to Euler form. So to convert this from polar form to Euler form, we're going to use this relationship. The modulus, or the length of this, the magnitude modulus, is going to stay the same from polar to Euler form. And then instead of writing cis in the angle, I'm going to write e to that power and the I there. So I'm writing this in Euler form: 10 e to the 2t plus 1 I plus 7 e to the 2t plus 3 I. Now, the reason we're doing this is we want to write this as a single, with a single variable t, and we want to be able to add the other parts together. So I'm going to write this as 10 e to the 2t I and e to the I plus 7 e to the 2t I and times e to the 3i. I'm just using the power laws here, instead of writing 2t plus 1 in parentheses I, I'm just writing this as 2ti times e to the I. Here I'm using the exponent laws. Instead of writing as e to the power of 2t plus 3, I'm writing this as e to the power of 2ti times e to the 3I. Now the reason I'm doing that is so that I can factor out our common factor, which is e to the 2t. And the whole reason we put it into Euler form in the first place is so that we can have a variable t in one of our factors, and everything else is going to be the sum of complex numbers without the t. So I'm going to factor out the e to the 2ti, and then I'm left with 10e to the I plus 7e to the 3I. Okay? And so this part right here does not have a t in it. So this is the sum of the complex numbers without t. And this part here is the factoring of 2ti. Okay, so now we're going to use our calculator to find the sum of these two things. So I'm going to get my calculator. Oh, and don't forget, I gave you this note. To get I, you're going to hit second in period. To get E, you're going to hit second in natural log. Okay, so I'm going to type this in here. 10 second natural log to get my E, and to get the power I, second in period. Okay, plus 7 second natural log to get my E, times 3 second in period to get my I, and enter, and then I get this value. So now I'm going to have e to the 2ti times negative 1.53 plus 9.40i. Okay, so I added 10e to the I plus 7e to the 3i, and I get this complex number. Okay, so just like the instructions here say, since the default of the calculator is complex numbers, the graphing calculator is going to convert this sum and write it out in Cartesian form. Okay, all I had to do was type this in, and then I hit enter. Okay, so now to do anything with this, I need to convert this into Euler form. So I'm going to convert this into Euler form. Okay, so in order to do that, I'm going to press math, this thing, and then press enter. Before I do that, I have to hit second and the button with the parentheses negative symbol to get my answer. Okay, so I've got my answer, the negative 1.539.4i. Right, that's right here. So I don't want to retype that in. I'm going to press press second and that little negative one there. And so it says answer, and now I'm going to type in these buttons: math, arrow over to CMP. So on my old-fashioned calculator it says CPX. On the newest calculators it says CMPLX. Okay, I'm going to go down to 7 to polar, and then I hit enter, enter, And so now it's going to convert it to polar form. So I'm going to rewrite this orange part as 9.53 times e to the 1.73 I. Okay, so I just rewrote it like that. Okay. So now I want to put just, I've got this factor, this factor, this factor. I'm just going to rearrange this. So I've got the 9.53 first times e to the 2ti times e to the 1.73i. Okay, all I did was rearrange this to put the 9.53 first. Okay, so next, so before I go on, what have we done so far? We factored out the 2ti in order to get this one term that has the t in it, and this complex number part does not have a t in it. This is what we have to do in order to write this as a single trigonometric function, not writing cosine twice. Okay, so we combine these two by using the calculator to add the imaginary terms, and then we converted it to Euler form. Okay, so now I rearranged the terms, and now I'm going to write this as 9.53, and I'm going to use exponential powers to write this with a single e. I'm going to write this as 2t plus 1.73i. Okay, and now I'm going to remember that we had this was that we're only dealing with the real part. So I'm going to write this as 9.53 cis 2t plus 1.73. And what I did was I just converted it from Euler form to polar form. But if I'm converting it from Euler form to polar form, remember the cis means that we've got cosine and sine, and we're only dealing in this example with cosine. So I have to put the RE because I'm only dealing with the real part, which is the cosine. Okay, so we're just about done. So since I've got the real part of this, my final answer is 9.53 cosine 2t plus 1.73. So our amplitude is 9.53. This is our period, 2t, and this is our phase shift. Now, in this course, we're only going to be adding waves that have the same period. There are going to be no examples or problems where the periods will be different for the waves. Okay, so and so here's what the graph looks like. Okay, so our 9.53 is this dark black wave here. Our first wave here is the one that goes really high and really low. Okay, you can tell it's got a greater magnitude, and this new one, the black one, is almost as high because it's 9.53. That's almost up to 10, and then the other one goes up to 7. Okay. So, noting that the resultant function has the same frequency period as the two original ones. So they all kind of repeat in the same amount of space. And I go to here, and it looks the same. I go to here, and the pattern looks the same. Okay, so this happens because the variable t was taken out of the common factor. However, the resulting function has different phase and than the original functions. Okay, and the maximum and minimums occur at different times than the other two original ones. Okay, so let's do this example now. Okay, so what's the first thing we're going to do? Since we're dealing with cosine, I'm going to write this as we're dealing with only the real part of 4 cis 3t plus 1 plus 3 cis 3t plus 4. Okay, so now I'm going to convert this to Euler form, right? Hit pause if you need to see this again. We're going to convert this to Euler form. So I'm going to write this as 4e to the power of 3t plus 1I plus 3e to the 3t plus 4I, right? Okay, I'm in Euler form now. So now I'm going to rewrite this as 4e to the 3ti e to the I plus 3e to the 3ti times e to the 4I. Okay, and now I see the same factor e to the 3ti here and here. I'm going to factor that out because I'm trying to get a single variable t, and I'm going to get it all into one factor. And so I'm left with 4e to the I plus 3e to the 4I. And I can get out my calculator. I'm going to type that in. Okay. 4e to the I plus 3e to the 4I. Okay, I hit enter. So basically I'm rewriting this here as 0.200 plus 1.095I. As we mentioned before, our calculator writes it as a compound, a complex, what did I say, compound? As a complex number. And so now I want to convert this into, I'm going to convert this into Euler form. So what did we do? We hit second x to the negative 1, so we have our answer. I'm going to hit math. I'm going to arrow over to CPX and over to polar and hit enter. And then enter. And now I can rewrite this here in polar form. So I've got e to the 3ti. I'm writing this as polar form 1.11 e to the 1.39 I. Okay. Let's rearrange these factors. 1.11 e to the 3ti times e to the 1.39I. Okay, now I'm going to write this with a single value of e, so 1.11 e to the 3t plus 1.39. Put that power in parentheses and factor out that I. Okay, we're almost there. Remember, we're trying to do the real portion of this. So we've got the real portion of 1.11 cis 3t plus 1.39. And so if I'm writing this as a single cosine wave in this form, I'm going to write it as 1.11 cosine parentheses 3t plus 1.39. Okay, and there we have it. That is our cosine wave, adding those two and getting a single cosine wave. Okay. I'm just going to walk through the answer rather than solving this all out. So first thing I'm going to do is write this as with the real and the cis. Change that cosine to cis. Okay, now I'm going to rewrite this in exponential form, in Euler form. So I have 7e to the power of 2ti plus 5 times e to the power of 2t plus 3i. Okay, you might want to hit pause when you want to check your work. Okay, next thing, I'm going to rewrite this e to the 2t plus 3i. I'm going to write that as e to the 2ti times e to the 3i. Then I see, okay, I've got this same factor, e to the 2ti, and I'm going to factor that out. And we're left with 7 plus 5 e to the 3i. And then I'm going to use my calculator to put this into, to add those together to get a single complex number, which gets me this using my calculator. Okay, and then and then I'm going to do the process to convert this to Euler form. Right? This was 2.168. Okay. And so I'm going to just rearrange these things. So the 2.168, I'm putting that over here. I've got e to the 2ti and e to the 0.3331i. So I'm just rewriting it and simplifying like we did in the previous example. And then I'm going to rewrite this in, what's the form called? I'm going to rewrite this, converting it from Euler form to polar form. And once again, this is cosine, so we're doing the real part. So the real part of 2.168 cis 2t plus 0.331. And so now we're finished. We've got 2.17, 3 sig figs, remember, and then cosine 2t plus 0.331. Okay, so this is our new amplitude. Okay. Now this one's a little different. So show that 5 sine t plus 1 plus 6 sine t plus 5, show that it gives me this. So remember that imaginary numbers we're going to be going up and down, which means we're going to be using sine rather than cosine. So if I've got, if I'm doing imaginary, um, this 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 here is the imaginary part of 5 cis t plus 1 plus 6 cis t plus 5. And so if it's the imaginary part, then I can rewrite this polar form into Euler form like this. So now I'm going to rewrite this as 5 e to the power of t plus 1I plus 6e to the power of t plus 5I. I just rewrote it from polar form to Euler form. Okay, and so now I can do part B. So we want to write 5 sine t plus 1 plus 6 sine t plus 5 in a single a single a single function. So so I'm just separating this out. 5e to the ti times e to the I plus 6e to the ti times e to the 5I. Okay, and now just like in the other examples, I'm going to factor out the ETI. This is the part with the variable, and we're going to end up with left with 5e to the I here plus 6e to the 5I here. We type it into our calculator, and we end up with 4.40 minus 1.55i, and then we convert it back to polar form, and we get this. We rearrange it to get this, and now we can put it, convert it back to polar form, and then when I'm back in polar form, now I can rearrange it. Since we're only dealing with the imaginary part, I'm going to, instead of writing cis, I'm going to write sine, because that is the imaginary part of this complex number is with sine, not cosine, because that would be the real part. Okay, so same process. Just writing, we have sine and sine, so we have imaginary cis 4t plus 8 cis 4t plus 3. I'm going to rewrite it in Euler form. So we've got 4ti e to that power plus 8e to the 4t plus 3I. Then I've got we've got this common factor we factor out, e to the 4ti, e to the 4ti. We've got that factored out, and so we're left with 1 plus 8e to the 3i. Right, let's just put a 1 there. Right. Okay, use my calculator. We get this imaginary complex number. Convert it to Euler form. On the calculator, we get this. Rearrange the 7.1.01, put that in there first, and then simplify this. We have e to the power of 4t plus 2.98 in parentheses I, and then rewrite this in polar form with cis. So we have Im for the imaginary part, because that's, we've got imaginary, we've got sine, 7.01 cis 4t plus 2.98. Okay, and then we've got our final function. Remember, this is our magnitude, or our modulus, whatever you want to call it. And this is our phase shift, and this is our frequency. You could also call this amplitude. So many names to call something. Okay. I'm just going to show the answer for this part here. And I guess I'll do question 4, and then I'll do 5 and 6 on a separate video. Okay. Okay. So I've got this function and this function. So first thing I'm going to do is I'm going to write im, because since it's sine, we're only focusing on the imaginary part of these two functions. 3 cis 3x plus pi over 12 plus 4 cis 3x plus 3 pi over 4. I'm going to rewrite this in Euler form, so we get 3 times e to the x plus pi over 2I plus 4 e to the 3x plus 3 pi over 4I. And then I can rewrite it like this and factor out the e to the 3xi. Right, I'm going to factor that out. This is challenging to type it into the calculator, so I'll do that with you guys right now. Somebody was showing me somebody in class forgot to type in the I. Ooh. Okay, so let's try to do this together. Second natural log e to the. I'm going to put this in parentheses. Pi divided by 2, close parentheses, I. Okay, see how I wrote it? 3 times e to the power of pi divided by 2I. If you've got a more modern calculator, it'll make it look like this. So like I said, somebody in this class forgot to write the I. I'm not going to tell you who it was to protect their innocence. They are not guilty if we don't know their name. Okay, to the power of 3 pi divided by 4, close parentheses, I. Okay, looks like I got it right. I hit enter, and we get, oh, is that a different answer than mine? How can that be? I wonder what happened here. A to the power. Oh. Oopsies, this is pi over 12, not over 2. How silly. Okay, so some of you want to retype this whole thing. No, you don't have to retype the whole thing. I can hit second and enter, and it has the whole entry. And I can just hit back arrow, back right there. And second delete, I'm going to insert a 1, so I have 12. And now I can hit enter. Whew. Okay, I did not want to retype the whole thing. So here now we've got 0.0693 plus 3.66 I. Okay, and then while we're at it, second, so we're going to do that answer. We're going to turn it to polar form. So what do we press? We press math, arrow over to CPX, down to 7, hit enter, and I'm going to convert that answer to polar form. And now I have e to the 3xi times 3.61 times e to the 1.55i. Okay. So, almost done. So now I'm just rearranging this in this order, and then I'm going to combine these things with the same powers, writing this e to the power of 3x plus 1.55i, and then finalize this by writing this back into polar form. We have 3.6i61 cis 3x plus 1.55, and this is an imaginary because we started off with sine. And so our final answer of f of x plus g of x is, drumroll please, 3.61 sine 3x plus 1.55. Okay, we're going to talk about questions 5 and 6, which are going to be on your test. Ooh.